In this video, we're going to talk about transformations using a cube root function. So A, H, and K still do the same things that they've always done, as we've talked about. So we're going to start by identifying those values. So in this function, we have 1/2 times the cube root of x minus 2 plus 3. So that means that our A value is 1/2. Remember that 1/2 means that we're going to have a compression. So compression means that I'm going to multiply our y values by 1/2 to create that compressed graph. Remember that I always do the compression first, and then I do the translation. So based on both H and K, my H value is 2. That means it's going to move to the right. And then our K value is 3. And that tells us that it's going to be translated up. So what we're going to do is, just like we did with the square roots, we're going to graph our table from example 1C this time. So the very first graph that we did with a cubic was the following 5 points. So we used -8, -1, 0, 1, and 8. And those gave us the f of x values of -2, -1, 0, 1, and 2. Okay. And so we're going to plot that parent function one more time just so that we have that shape here. Oops, I plotted that at 1. So 8, 2, not 8, 1. And then -1, -1, and then -8, -2. Okay, so that's our parent function in pencil so that we can kind of keep this organized. So that's f. Remember that with the compression, what we're going to graph next is, instead of using those y values for f of x, we're going to multiply them by 1/2. So we're going to take half of -2. So half of -2 is -1. Half of -1 is -1/2. Half of 0 is still 0. Half of 1 is 1/2. And then half of 2 is 1. So we're going to next plot the points -8, -1. Okay, so it's squeezing down by half. -1, -1. Oh, I plotted the wrong point there, sorry. -8, -1. -1, -1/2. 0, 0 staying the same because we're squeezing towards 0. 1, 1/2. And then 8, 1. And so notice that our graph got pushed towards the x-axis in this compression because we're compressing it vertically, so we're compressing it closer to the x-axis. And then the last thing that we're going to do is move every point 2 to the right and up 3. So in the case of our first point, when I go to the right, I am off the graph, and then up 3, I'm kind of up here with my table. So let me move that table before I graph this, just so that we have a little bit more space to see what's going on. Okay, so if I move the table down here, then I have the room. So we're going to graph this where that each point moves to the right 2 and up 3. And so again, our first red point, right, we're ignoring the gray now, because that was our parent function. We're now graphing the compressed function. I'm going to go right 2, so I'm going to estimate where 2 is, and then go up 3. So I'm going to be at the point, let's just draw the table over here. Actually, let's just write this on the end. Our g of x, we just moved that point that was at 8, 2 originally. To 10, 4. Okay, so our point that was at 8, 2 moved to 10, 4. Our point that's at 1, 1/2, we're going to move it to the right 2, so we're going to be at 3. And then from 1/2, we're going up 3. So that means we're going to be at 3 1/2. Then 0, 0, we're going to move right 2, up 3. So we're going to be at 2, 3. And then at -1, -1/2, we're going to go to the right 2. So we're going to be at +1, and then up 3. So we're going to be at 2 1/2. So 1, 2.5. And then finally, we're going to move the point -8, -1, right 2. So we're going to be at -6, up 3. We're going to be at -6, 2. So our graph now looks like this with those transformations. So if we look at the connection with our patterns, notice that again from our HK, this is going, we're subtracting 1, then we're subtracting 7, just like we talked about. And then we're adding 1, adding 7 is our pattern. And then our A value was 1/2. So notice that if I add 1/2 each time, that's going to give me the next value. So in general, if I'm graphing a cubic, what I want to think about in terms of my table is that I have 5 points. The middle point is always going to be HK. From that point, I can either remember the pattern that I'm going to subtract 1 and then subtract 7. And then to go down, I'm going to add 1, add 7. Or I can think about this number as -8 plus h, as -1 plus h, as 0 plus h, as 1 plus h, as 8 plus h. Okay, so I'm looking at the perfect cubes that we talked about from -2 to +2 cubed to get those x values. So you kind of have this, these two different options to figure out those values. The other thing that we did in the beginning was we talked about, okay, if I want something -2 to be -8, what do I have to subtract 2 from? Is how that -6 came about, right? And then 1 minus 2 makes -1. So really you have 3 options to figure out those x values. And then for the y values, it's always, I add 1/2 to get the next value. So that pattern is 1/2. So that means since I'm starting at the middle, because I have to go backwards, I'm going to subtract 1/2 from k to go up. I'm going to subtract 1/2 from that value to go up. So when we're graphing a cubic function, it's similar to all of the properties we talked about with square roots, but it is a little bit more complicated because it's a pattern you're not used to.